Good morning. In session number 6 of design of compression members, I will be introducing you to design of short column subjected to axial load and uniaxial moment. When a column is subjected to an axial load and moment in any of the one principal axis, we call these types of column as axially loaded and uniaxial moment type of columns. Generally, these types of column occurs when the load are applied at some eccentricity either along any one direction of the columns. In this particular type of column, the column will be subjected to both axial force as well as a moment. For the design of such columns or columns with axial load and uniaxial moment, we'll be using design charts from SP16. Generally, SP16 has got 3 sets of design charts, and for rectangular and circular or type of cross sections. The 3 sets are as follows. The chart number 27 to 38 are the first 12 charts for rectangular columns having symmetrical longitudinal bars in 2 rows for 3 grade of steel, that is Fe250, Fe415 and Fe500. Each of them has 4 values of D dash by D ratio, that is 0.05, 0.1, 0.15 and 0.2, where the D dash is the cover provided, the effective cover provided for the columns. And chart number 39 to 50 are the second set of 12 charts for rectangular columns having symmetrical longitudinal steel bars distributed equally on 4 sides for 3 grades of steel, that is Fe250, Fe415 and Fe500, and for 4 different values of D dash by D, that is 0.5, 0.05, 0.1, 0.15 and 0.2. Third set of 12 charts numbering from chart number 51 to 62 are for circular columns having 8 longitudinal bars of equal diameter and uniformly distributed circumferentially for 3 grades of steel, Fe250, Fe415 and Fe500, and each of them for 4 values of D dash by D, that is 0.05, 0.1, 0.15 and 0.2. All these 36 charts are prepared for M20 concrete only, and this is just an approximation, and it is not worthwhile to have separate design charts for each grades of concrete. Approximation and limitations of design charts for SP16 are the grade of concrete. As explained to you that all the charts have been derived for M20 grade. However, each chart has 14 plots having different values of P by FCK ranging from 0 to 0.26 at an interval of 0.02. Hence, the designer can make use of the actual grade of concrete by multiplying P by FCK obtained from the plot to the actual FCK for the particular grade of concrete to partially compensate the approximation. Three sets of charts has got the fixed value of D dash by D. However, in practical designs, d dash by d ratio may vary from those values. In such situations, immediate values should be determined by the linear interpolation. And the third point is the equal distribution of 20 longitudinal steel bars on four sides of the rectangular column. The design chart may be used without significant error for any number of bars. Since in the design chart it has mentioned as 20, it is not mandatory to consider 20. It can be used for any number of bars greater than 8, provided the bars are distributed equally on four sides. In mind, the distance between the two bars, we can arrange the bar equally on four sides, and it is not mandatory to keep the bar as 20 number. We can vary, but it should not be less than 8 numbers. Longitudinal bars in circular columns, though the design chart prepared considers 8 bars uniformly placed circumferentially, they may generally use for any number of bars greater than 6 uniformly placed and circumferential. These are all some of the approximations that we need to know before getting into the design of columns. So, recalling the approximation, since the charts, all the charts, design charts have been prepared for M20 concrete, we have charts of P by FCK ranging from 0.0 to 0.22. Hence, the PU by FCK factors need to be multiplied for the given FCK in order to reach the approximation or in order to reach the assumed grade of concrete. And the number of bars, we can place any number of bars uniformly throughout, but not less than 8 numbers in rectangular section and not less than 6 members. By keeping these approximations in mind, we'll be moving ahead for the design of short spiral column subjected to an axial load of 2100 kilonewton and a moment of 185 kilonewton meter. The grade of the concrete is M25 and grade of steel is 4 and 5. The preliminary diameter of the column may be taken as 500 mm. So here, the step 1 of this particular design is to select given F1, Fe4 and 5 and D dash by D. The chart selected for this problem is chart number 56 of SP16. In order to determine the percentage of longitudinal steel in the step 2, with the given grade of concrete and the assumed depth of 500 mm, we need to calculate PU by FCK BD square, MU by FCK D cube. And the particular point or coordinates of PU by FCK BD square equal to 0.36 and MU by FCK D cube is equal to 0.06. It need to be plotted in chart number 56, which gives the P by FCK has 0.08. Hence, the percentage of steel calculated depending upon the given data is 2%. Therefore, the area of steel is 3928.57 millimeter square. For the required area, we provide 8 number of 25 mm diameter bar, which is having an area of 3927 millimeter square, which is marginally less than the steel that is required. And will be checked considering the enhancement of strength of the spiral column as stipulated in clause 39.4. Design of transfer reinforcement. The diameter, as explained in the previous problem, the diameter of helical bar here is taken as 8 mm because as per IS 456 diameter should be the maximum diameter of the longitudinal reinforcement divided by 4 or 6 mm. So 25 divided by 4 gives me a value of approximately 6.5, which is greater than 6. Hence, I am assuming die of bar as 8 mm. Pitch is calculated as per the clause 39.4.1 of IS 456, where the dia of core is equal to the diameter of the column minus the cover on either sides, and grade of concrete is given as 25 Newton per millimeter square. Grade of steel is 4.1 and dia of spiral reinforcement is 8 and the area of spiral reinforcement is 50 millimeter square. Using the above values, we have P, pitch should be less than 25.716. As per clause 26.5 regarding the pitch, the pitch of the spiral, the pitch should be greater than dia of core by 6, or the pitch should be less than or equal to 25 mm and 24 mm. So the pitch of the spiral is 25 mm is okay. Therefore, this is the figure which represents the spiral and the longitudinal reinforcement provided. This is the revision of design if required. So whatever the data that we have provided, we need to cross-check whether any revision is required. So providing 25 mm diameter bar and 8 mm diameter spiral, we have the effective cover as 40 plus half of 8 plus half of the dia of the longitudinal reinforcement, which leads to 60.5 mm. Hence, this gives d dash by d to 60.5 by 500, that is 0.121. In step 1, the d dash by d was assumed as 0.1. Hence, the revision of the design is needed in this particular problem. However, the area of steel required is not provided. Hence, this may be the offset considering the enhanced strength of the spiral column as stipulated in the IS 456. Therefore, we assess the strength of the design. When d dash by d is 0.121 and area of steel provided, it can be subjected to a load of 2100 kilonewton and a moment of 187.5. For the purpose of assessment, we determine the capacity of the column when the moment is 187.5 kilonewton. Further, the revised d dash by d needs to be interpolate the values of chart 56 and 57. So the value of P by FCK is 0.08 and mu by FCK BD cube is 0.06. Therefore, from the above charts and interpolation, we get PU as 2005.5 kilonewton. Thank you.